In the last lesson, we looked at the brief introduction to row reduction, and now we're actually going to begin the process of row reducing a matrix to solve a system of equations. So, in this first problem here, first step is always to create our matrix based on the system of equations using the coefficients and the answer column. What our first step always should be is to get this bottom left entry into a zero. Well, the only way I can do that is if it is the same as the entry above it, but I want to have opposite signs. So the way I'm going to first do that is by taking that entire first column, the entire second row, and divide it by -1. That means I'm not changing the first row at all, but I'm going to make the second row into a -1, +1, and -30. Because now what I can do, since I have these two guys the same but opposite, I can add those two rows together. If I plug it into row 2, that means this guy here will become the 0 that I want it to be. So, that first row still is the same because I'm not plugging anything into that row. It should be 110. And the second row now will be 1 plus -1 is 0, 1 and 1 is 2, 110 and -30 gives you 80. Okay, after everything below the diagonal is a 0, which it is because here's the diagonal, I next want to make this entire row, or make this entry, the pivot position, into a 1. So to do that, what I'm going to do is I'm going to take row 2 and divide it by 2. That's the only way I can change a pivot position, turning it from a number into a 1. So the first row is still the same. It's still 1, 1, 110. My second row now will be 0, 1, and 40. From here, what I'm going to do is I need to now make everything above the that pivot position into a 0. So to do that, same sort of idea we did before, I need to take something to make a linear combination. Well, I have a 1 and a 1, I need to have a -1. So again, I'm going to divide row 2 by -1. So that'll be 0, -1, -40, and this will now be still 1, 1, 110. Because now I can combine these two rows, combining row 1 and row 2, I now want to plug it into row 1 because this is the guy who I want to make into a 0. So because of that, when I add them together, I get 1 and 0, because 1 and -1 is 0. 110 plus -40 gives me 70. This becomes 0, -1, -40. So everything above the pivot position is now a 0. So now I just need everything to be 1s on the diagonal. Well, the first row is already in that shape, so I have nothing to do there. The second row, however, I just need to divide it back by -1 again to make it 0, 1, and +40. So that's why my answers here are x equals 70 and y equals 40. Let's look at another example, a little bit more complicated. All right, first start by getting our matrix written. So I'm going to have 4, 1, 13, -2, 3, -17. Again, your first step needs to be getting this position in the bottom left into a 0. The only way I can do that is by making it the same but opposite sign as the guy above it. So to do that, I need to take that second row, multiply it by 2. My top row is still the same. Remember, I don't touch the top row till the end. This becomes -4, +6, and -34. Now these are the same number, different signs. That means I can combine them. So I'm going to take row 1 and row 2. I'm going to plug it into row 2 because, again, this is the guy who I want to make into the 0. So my top row is still the same. My bottom row, 4 and -4 gives you 0, 1 and 6 gives you 7, -34 and 13 gives you -21. Okay, I now want to make this guy into a 0, or I'm sorry, into a 1, because I can't combine yet with this guy. But if I make it into a 1, actually I want to make it into a -1. So I can even say right now, take row 2, if I divide it by 7, that would give me in that second row 0, 1, and -3. However, since this top row is 4, 1, and 13, to combine them, I'd want this to be a -1. So if I divide this by -7, then I'd have -1, +3 to be able to combine these guys. So now I can combine row 1 and row 2. I want to plug it into row 1 because that's what I want to turn into my 0. So when I do that, plugging it into row 1, 4 plus 0 is still 0. 1 and -1 is 0 like I wanted. 13 and 3 gives you 16. Bottom row stays the same. Okay, my last step, I need to make my diagonals into 1s. So I'll take row 1, divide it by 4, row 2, divide it by -1. Now let's do this all in one step. So it'll be 1, 0, and 4, 0, 1, and -3. So my final answer should be x equals 4, y equals -3. We'll look at one last example together here. So let's set up the matrix. 6, -1, and 4 for the top row. -4, 1, and 2 for the bottom row. Again, make sure that you're paying attention to your negative and positive signs here. Okay, what I'm first going to do is I need to somehow eliminate this guy in the bottom left. Well, I should be asking, can I multiply by anything to get to the top row or vice versa? No, I really can't. However, what I can do is I can find the least common multiple here. That least common multiple of 12 is what I'm going to need. So to do that, I'll multiply the top row by 2 and the bottom row by 3. That way, I get numbers 12, -2, and 8 in the top row, -12, 3, and 6 in the bottom row. Now I'm going to be able to eliminate because I want to turn that into a 0 and I have the same numbers to work with 12 and -12. So I'm going to add my two rows, row 1 and row 2, plug it into row 2 because that's where I want to eliminate. So my top row is 12, -2, and 8. My bottom row is going to be 0, 1, and this guy should be a 14. Alright, so now from here I need to somehow find a way to eliminate everything above the diagonal. So this -2 needs to somehow become a 0. Well, I have a couple different options here. I can either multiply this 1 and 14 by 2. That way I'd have 2 and 28. I would be able to combine them that way. Or my other option, everything in this top row can all be divided by the same number. I mean, we already multiplied it by 2. I can divide it back out by 2. So I'm going to do that first. Take row 1 and divide it by 2. So now I have 6, -1, and 4, like I did in the beginning, with my 0, 1, and 14 that I have. Now I should be able to add row 1 and row 2 because I have the same number but opposite sides. I'm plugging into row 1 because that's the row that I want to eliminate. So my bottom row stays the same because I haven't changed it. Top row is going to be the sum. 6 plus 0 is 6, -1 and 1 is 0, 4 and 14 is 18, and then my last step is just to take that top row. I need to turn this pivot position, leading entry, into a 1. So I'm going to divide by 6 to do that. So I have 1, 0, 3, and 0, 1, 14. So my final answer should be x equals 3 and y equals 14. Alright, here's two more examples. I even gave you the answers. I'd say pause the video and then come back when you're ready. I'm just going to reveal the answers and kind of talk through the steps to get there. Alright, so looking at this first one, let's reveal the answers here. I have the matrix set up as such. I need to make this guy a 0, so multiply by 2 to do so. That way I can add these guys together, and that's how I get my 0 here. I add the rest of the entries to get -1 and +2. From there, I already have these guys the exact same and opposite sign. Perfect, so I can just add immediately. Adding these guys together, I'm going to plug into row 1, because again, row 1 is what I need to turn into my 0 in this case here. Just like I needed a 0 here to begin with. So I get 2, 0, 6, again with the 0, -1, 2 that I already needed. Divide each of those rows by the leading entries to get x equals 3 and y equals -2. For the second guy, much like the last example we did together, need to combine a couple things going on here. Let me get this actually on the screen, might help a little bit. Okay. So I need to multiply top row by 4, bottom row by actually a -3. That way I got my opposite sides to cancel out. Okay, I get, when I add them together, top row is still the same, 0, 5, and 35. What I did from here, I divided by 5 to get 0, 1, and 7. When I went to combine there to the next row, we had a couple different options. Again, I could have multiplied the bottom row by 4 to combine them. Another option was I could have divided the top row all by 4 to have gotten 3, -1, and 5. There's no right or wrong way to do it. Either way will work just fine. In the end here, I divide by 12, the way I have it written in green. If I had done it the other way, I would have divided by 3. Either way, you should still get the identity matrix with your augmented column of 4 and 7.